Welcome to Solar Power Math. I am Susanna Solar and I am so excited that you're here. We're going to talk about simplifying radicals and specifically square roots in this little lesson today. I've got 4 examples, so let's get right into it. I want to start by saying there are a few ways that you can simplify radicals and they are all right. I'm just going to show you one strategy that's always worked for me, and hopefully it will help you too. So to simplify radicals, we want to start by looking at the number inside the radical and break it down into what multiplies to get 52. And it can be anything. There's not a particular set we're looking for. So the first thing that jumps to my mind is 2 times 26. And then we want to keep breaking down each of these numbers until they are completely prime numbers. What's a prime number? It's a number that is only divisible by 1 and itself. So the number 2, what multiplies to get 2? Just 2 and 1. 1 in itself. So that means 2 is prime. So I'm going to put an underline to remind myself that that is a prime number and we are done with it. 26, I know it's not prime because it's even. So I know we can multiply 2 and 13 to get 26. I know 2 is prime because we've already discussed that. 13 is 13 times 1, so it's a prime number. So we have all prime numbers on our bottom branches of our little tree that we've got going on here. So to simplify the square root now, we are looking for pairs of 2 of the same number. Because in a square root, we technically have a 2 right here on the outside of the radical to say square root. So I have a pair of 2's, and once you have one group, that group gets to come out of the radical, but only one of them. So it's just going to be 2 because it represents the group of 2's. And then 13 does not have a pair, so it has to stay underneath the radical. And so 2 square root 13 would be our final answer. For 200, first thing that comes to my mind is 2 times 100. 2 is prime. 100 can keep getting broken down to 4 and 25. Well, 4 is 2 times 2, which is prime. 25 is 5 times 5, which 5 is also prime. So we have all prime numbers at the bottom, and we are looking for groups of 2 of the same number. So I see a group of 2's. It gets to come out of the radical. A group of 5's comes out of the radical, and it joins the 2 by multiplying. And then we have a lonely 2 up here that has to stay in the radical. So we have 10 square root 2 as our final simplified answer. All right, 30. 30 is 6 and 5. 6 is not prime because it can be broken into 3 times 2. 3 is a prime number because it is 3 times 1. So 1 in itself. 2 is a prime number. 5 is a prime number. So we have no 2 numbers that are the same, 3, 2, and 5. So when that happens, when none of your bottom branches of your little tree, it's called a factor tree, that's why I keep calling it a tree, when none of them are the same, that means that square root 30 was as simplified as it could be. So we were done. All right, last one, 350. I know that that is 35 times 10. And 35 is 7 times 5. 7 is prime, 5 is prime. 10 is 5 times 2. 5 is prime, 2 is prime. So we have all prime numbers and we're looking for groups of 2. I see 2 5's, so that will pull out of the radical. The 7 does not have another 7 and the 2 does not have another 2. So they will stay in the radical and multiply with each other. So that is 5 square